Have you ever tried opening a chocolate bar by splitting it right down the middle? That's exactly how the identity we are learning today works. It takes a square expression and splits it into two linear brackets. We are talking about the identity a squared minus b squared equals open bracket a plus b close bracket into open bracket a minus b close bracket. This is known as the difference of two squares, a very handy trick for fast factorization. It works only when both terms are perfect squares and are separated by a minus sign. Let's dive in and see how beautifully this identity simplifies a variety of expressions. Let's begin with the most direct case. Suppose we are given 4x squared minus 169y squared. Now let's rewrite this as open bracket 2x close bracket squared minus open bracket 13y close bracket squared. Clearly, both terms are perfect squares. So we apply our identity, a squared minus b squared equals open bracket a plus b close bracket into open bracket a minus b close bracket. Here, a is 2x and b is 13y. So, the factorized form becomes open bracket 2x plus 13y close bracket into open bracket 2x minus 13y close bracket. And that's it. Quick and elegant. Let's try a variation where the square is written as a bracketed expression. Suppose we have 1 minus open bracket b minus c close bracket squared. Now notice this is again of the form a squared minus b squared. We write 1 as open bracket 1 close bracket squared and b minus c as open bracket b minus c close bracket squared. Now, applying the identity a squared minus b squared equals open bracket a plus b close bracket into open bracket a minus b close bracket. So this becomes open bracket 1 plus open bracket b minus c close bracket into open bracket 1 minus open bracket b minus c close bracket. Simplify the expressions. First bracket becomes b minus c plus 1. Second bracket becomes minus b plus c plus 1. So final factors are open bracket b minus c plus 1 close bracket into open bracket minus b plus c plus 1 close bracket. Even complex looking terms can be handled if you apply the pattern carefully. Here's one where we need to rearrange and group. Let's take x squared minus 2y plus xy minus 4. Step 1. Rearranging, we write it as x squared plus xy minus 2y minus 4. Step 2. Group terms. Group 1, x squared plus xy. Group 2, minus 2ya minus 4. Step 3. Factor each group. From the first group, take x common x into bracket x plus y. From the second group, take minus 2 common minus 2 into bracket y plus 2. Now observe the brackets are not the same yet. Let's rewrite the middle part to match it. Wait. We can't directly factor this using the difference of squares identity, but this still shows how grouping and rearranging are key steps to apply identities or detect common factors. Let's now tackle a binomial expression involving variables given a into bracket a minus 3 close bracket minus b into bracket b minus 3 close bracket. Let's expand both terms. First term becomes a squared minus 3a. Second term becomes b squared minus 3b. Now put it all together. A squared minus 3a minus b squared plus 3b. Rewriting. A squared minus b squared minus 3a plus 3b. Now group open bracket a squared minus b squared close bracket minus 3 into bracket minus b close bracket. We've got the first part a squared minus b squared, which factors as open bracket a plus b close bracket into open bracket a minus b close bracket. And the second part is minus 3 into open bracket a minus b close bracket. So the final expression is open bracket a plus b close bracket into open bracket a minus b close bracket minus 3 into open bracket a minus b close bracket. Now observe both terms contain a minus b as a factor. We can factor further if needed. This is how the identity and algebraic expansion work together. Let's quickly revise what we've learned about the difference of squares. We use the identity a squared minus b squared equals open bracket a plus b close bracket into open bracket a minus b close bracket. We learned that it only applies when both terms are perfect squares. It requires a minus sign between the two squares. Rearranging terms or expanding brackets may be necessary to see the pattern. Once applied, this identity simplifies even complex expressions into neat factors. I hope now you understand how and when to use the difference of squares identity. Practice it with different forms brackets, coefficients, and algebraic terms. And that's the foundation of how we factor using the identity a squared minus b squared equals a plus b into aa minus b. In the next video, we'll explore how to factor perfect square trinomials and connect identities with real-world algebraic problem solving. See you there.